Hey guys, so, sorry. All right, so what we got here, these were the notes that we took, Thursday in class. So, thermal energy, type of kinetic energy, is the energy of movement of particles of matter. And we started off talking about this kinetic molecular theory. So basically what this is saying is as the temperature changes, the state of matter also changes. And that is essentially the states of matter are dependent on the amount of energy in these particles or atoms. So I found this and I thought it was pretty good about describing it. So if you look, now remember the length of the arrow represents how much energy or how much force there is with it. So the lower the kinetic energy, the lower the absolute temperature, which makes sense since temperature is a measurement of how much thermal energy something has. Higher average kinetic energy is a higher absolute temperature. If you look at this did a much better job of trying to describe what I was trying to show you in class the other day. So back to this stuff. Remember, volume is the amount of space that something takes up. And we got into talking about what temperature is, the definition of it. So how much measurement of how much thermal energy there is in an atom. And then, just kind of recapping here for you. And then we talked about heat. This is the scientific definition of heat. Not heat as in temperature. In everyday life, we use heat interchangeably with temperature. Turn up the heat instead of turn up the temperature. Or the heat index. Okay? Heat index. If you look at the definition, the scientific definition, it's the movement of thermal energy. Well, that absolutely makes no sense when it talks about weather. Okay? So movement of thermal energy. And this movement happens in a very predictable way. Actually, energy or almost anything in nature, like we said, happens in areas from high to low. This is cloud formation. This is atmospheric pressure. What am I trying to say? Weather fronts is high to low pressure. The reason why it gets super windy before a cold front is all because of things moving from areas of high concentration to low concentration. Okay, so there are three ways that energy transfers. The first one we talked about is conduction, and I showed you, where'd it go? I showed you this, okay, where if we were able to see the atoms in this metal blade, we would see the atoms banging into each other and traveling across, melting. Okay, so the next thing, okay, so you're gonna add to your notes from here. So what we have, think of dominoes. So there will be a good, why is this not working? Seriously? Here we go. Okay. So dominoes stacked, falling over, hot. I know we talked about this as not being super technical and you guys were able to go a little bit further with this, but hot stove plus hand equals burnt. Okay, anytime that you have contact, okay, and this is going to be contact of atoms. Okay, so from here, after conduction, we have the other one that starts with a C, and that is convection. Okay, again, I have the T-I-O-N ending, so I have process of. Okay, and this is process of energy transfer by hotter, expanding fluids rising and cooler contracting fluids DS sinking. Okay, so typically, and I don't think I have a red pen here, but typically we'll see these as currents, okay? So we're going to use purple for blue and orange for red because I don't have red and I don't have blue with me, okay? So, all right, so what is happening here? Oh, by the way, let's talk about this fluid here. Fluids. Okay, I hope you can see that. So fluids. Fluids are liquids or gases. And we talked about this yesterday in class. But this aerodynamics is the study of fluids and how they behave. Air moves very similarly to water. Okay, so what happens, and this goes back to the kinetic molecular theory. So if we go back and look at this picture for a second, okay, maybe not that picture. Let's go this one. Okay, so if we go back and we look at this, a solid, as things heat up, they begin to have more energy. And if you think of it simply as people, the more energy that you have, the more you tend to move around. Let's just face it, that's kind of how it is. As these things move around and the temperature increases, the volume that they need also increases. Okay, that's not a good one. Anyway, so the more they move, the more they expand. Well, this is pretty good. Okay, so you go from this crystalline structure here to the same amount taking up more space, and then they fill up the entire container. All right, so convection. The reason that it happens is you have, as let's say my heat source is down here. Okay, or whatever. So down here, as atoms come into contact with the heat source, they are going to be heated up. As things heat up, if I were to look at whether it be a gas or whatever, okay, let's say that's what the atoms are going to look like. As they're heated, they expand, which means they become less dense. Okay, as they sink, become more concentrated together, they contract. Okay, oops, cooler contracts, and so, oops, sorry, off page, contracts and sinks because it is more dense. Okay, now remember, density. Density is how, oops, what am I writing? I have no idea. How much matter is packed into a given space. Okay, so let's pretend that these two boxes here were the exact same size, that I could actually draw them to be the same size. Let's say it's the size of a quarter, okay? So if you have an area the size of a quarter and you have fewer atoms in it compared to this one and you have more atoms in it, this one is more compact. It is more dense, okay? When things cool, they will contract. If you are looking at, let's say you have, let's just pretend and say you have 100 atoms. They're going to shrink more than they will up here. Now, there is an exception for when cooler things contract. The exception is H2O. This is the only thing that we know of that as it cools, it expands. Water expands. That's why we have weathering. That's why rocks will crack. That's how we end up with potholes and stuff like that. Okay? But anyway, so back to convection. Convection currents happen with heating and cooling in this circular fashion. No matter the size of the space, this is going to be happening. okay? All right, so with convection, sorry, off on a tangent here. It's been a long day. Okay, so some examples of convection currents. Convection currents. Where do we find these sort of things? Okay, so you're going to find them in the Earth's crust. Okay, in the magma and the mantle. You're going to get into that in 8th grade for sure when you talk about geologic history and the layers of the Earth and all that really cool, awesome stuff. We talked about that a little bit last year. Okay, so you have the rising and the falling of the magma because it's hotter at the center and cooler towards the top. So you have that. It happens in the oceans. Okay, that's how you get the ocean currents. Ocean currents. Okay, atmosphere. You have it in your house. If you live in if your house is 2 levels. I have a split level house, and there are times like last weekend when it was pretty nice out, you could feel the temperature difference big time. It was much hotter at the top than it was at the bottom, and you could almost feel the air moving. Sounds a little crazy, but it's true. Okay. Convection currents, the birds that soar, like hawks and eagles and things like that, when you see them out like soaring, they're riding convection currents. They're riding updrafts of the air and the downdrafts, so they don't have to flap their wings as much. Okay, so convection. Oh, let me show you this. So convection. Okay, I'm going to. Is this the one I want? Yes. But I'm going to turn the sound off because it doesn't matter. And I'm going to speed this up. Okay, so he's got this little doodad. Actually, I just let it play. I hope this is recording. Yes. All right, so filling up that little tiny, I mean, obviously you can see how big it is compared to the size of his hand. And he's taking red dye. It's just food coloring. Making it very obviously different colors. If you hear me crunching in the background, I'm eating my apple, so don't worry. So he's heating it up. Doesn't want to heat it up too much because you don't want it to boil, because then you have a whole nother demonstration going on. Takes that hot flask, has a stopper in the top that has a straw essentially that goes down to the bottom and then up at the top, so it creates kind of a chimney effect. And you can kind of see what's happening. So the red dye is coming out the top, but it's pretty much staying at the top. Okay. Heated water rises, and we talked about that. And the reason why is it is less dense, and you can almost see, you see the definite separation of the layers. You see a little swirling happening right here, but not a whole lot. I mean, this is a pretty good defined line. And he speeds it up for you here. Still going. Now watch. It is almost shockingly fast as to how quickly it starts to dive down. So you have the ice over here, and we talked about yesterday how ice isn't really cooling the liquid. The liquid is cooling the ice. So this in the jug here, I'm going to pause this for just a second. This in the little flask is hot. The red stuff is hotter. You're cooling that down. So you almost have 3 different temperatures. Well, you have quite the range of temperatures going on here. But you've got this coming down here. Now notice, as it's touching this flask right here, what's happening as it is going back up, it's reaching another heat source, which is the hotter water, because you know that glass is hot, and it's going back up the top, as well as that steady stream is still coming out. And he's going to close in here, and you can see the swirling right there. Now, if he added ice to the other side, you would see the same thing going in the other direction. Okay? I'm going to speed this up a little bit. So what he has here, this is, I don't really know what it is. You can, I did this in the past with like Pert Plus, like that 2-in-1 shampoo. So what you do, down here you have this whole beaker full of whatever, and a Bunsen burner going here. So we're going to heat it up. I think it's going. You can see the heat. You can see it starting to rise. And it's almost like in waves. And that's pretty much how it goes. Now you'll notice up at the top, it's not boiling yet. What I want to show you is here. You've got this spot, you've got this spot, and you've got this spot. And it looks like there's another one starting over here. You can have multiple convection currents going on in one location. If you think about the ocean, like, I don't know, I'm thinking of like Finding Nemo and the turtles bit, oh my goodness, whatever it is, the thing that dumps them out there at Sydney. Anyway, so those types of things are created by this, okay? All right, so convection. The last thing that I have for you, I know this is going on for quite a while, I'm sorry, is radiation, okay? Radiation. This is the process of energy transfer using electromagnetic waves. Okay, so if you think back and remember to our transverse wave stuff, okay, the electromagnetic spectrum, the frequency increased and decreased, and you had different types of energy along this line. You had, we had gamma rays, we had microwaves, we had infrared waves, and I can't remember the order of all of them, but somewhere in here was the visible light spectrum. All of that is energy transfer, all of that is thermal energy in a way that it can be transferred. Okay? Yes, no, maybe. So examples of this. I mean, literally microwaving your food is an example of this. Sunlight. Light from the light bulb. Light from light bulbs. Heat from the fireplace. Heat from the fire. Okay. Heat from the ground. Okay. There is heat rising up through the earth. So there you go. Okay. So using this, what you guys are going to do next, in Google Classroom, you will find a link to this. Okay. You are going to, I really hope this works on Chromebooks. Fingers crossed. It should. Maybe we'll try that. I don't know. Anyway, so you're going to go through this. I want you to take notes. There are different, it's going to pull this up, I hope, for you. You have next down here in the corner. What is thermal energy? Manipulate this. What happens when you do that? So for each screen, there's something for you to do. I want you to do it, and I want you to tell me what you learned. Next, convection, radiation. This one's actually pretty cool. This is where we start to make all those connections that you guys like to ask me a bunch of different questions. Be sure you click here on each one. Campfire. You kind of see each thing going on here. Life science. Technology. There you go. Okay? Have fun. Good luck. Be good.